So the first manometer we have here is where the gas pushes more onto the atmosphere, which is opened, which means that the pressure is going to be higher on the atmosphere, which is 760 mm. Now what we need to do is we need to find the height between the gas and the atmosphere. The gas looks to be around 300 and the atmosphere looks to be about 500. So after we find that, what we are going to do is we're going to find the difference between the two, and that's going to give us 200. And now since the gas pushes onto the atmosphere, we're going to take the 200 and we're going to add it onto the 760, which is going to give us 960 mm Hg. And this would be the pressure for this manometer. Now on this manometer we have an open atmosphere which is pushing down on the gas, so the gas is higher than the atmosphere. So to find the vapor pressure, the final vapor pressure for this manometer, we're going to have to find the height for the atmosphere right here, and the height for the gas right here, which it looks to be around 800 and 300. So we're going to want to find the difference between that, and that is going to give us 500 mm. And now because the atmosphere is pushing down on the gas and the gas is higher, we're going to use this 500 and use the 700, bring the 700 down here, 760, and subtract 760 from 500, which would give us 260 mm Hg, and this would be your final vapor pressure for this manometer. So here we have a manometer where it's opened on the atmosphere side, but it is the same here. It has the same height for the gas in the atmosphere. So it doesn't really matter where the height is at. It is basically 0 plus or minus the 760, and that is going to give us either way 760 mmHg. So this is going to be your vapor pressure for a manometer where it has equal pressure. So for this same manometer, I got the 0 because since the atmosphere and the gas are equal, they have 0 difference. So that's where I got that 0 from. So here we have a manometer where both sides are closed. Both sides of the gas and the atmosphere are closed. But we're going to use the same process. We're going to find the height of the gas, which it looks to be right here around 600, and the height of the atmosphere, which looks to be around there, 300. So we're going to keep doing the same thing. We're just going to subtract 600 minus 300, and that's going to give us an easy number, 300. And we don't need to do anything else since both sides are closed. We don't need to find the difference between 760 or add it. So this is going to be your final vapor pressure, mmHg. Okay, so for this final manometer, we have it closed. We have a closed manometer, and the atmosphere is being pushed by the gas. So we're gonna keep doing the same process. This looks about to be like 650, I guess. Looks to be around 650. So let's just write 650 here. and this looks to be around 300. So we are going to find again the difference between those two, and it's going to give us 350, and that would be our final. That would be our mmHg, since both sides are closed of the gas in the atmosphere. That would be the final vapor pressure, 350 mmHg.